Okay, so this is Webwork problem number 10 on partial derivatives. The question is, let f of x comma y equal f of x minus y to the eighth. Then, so we have the first question is the partial derivative of x. So we have to find that first, and then the partial derivative of y based off of that. So our problem here is 5x minus y to the eighth. So when we take the partial derivative of that in regards to x, we get 8 parentheses 5x minus y to the seventh times the derivative of x. We gotta make sure that it's only the derivative of x and not y, because again we're starting with in regards to x. So when we multiply this out, we get 40 5x minus y to the seventh. Now, we're not done for this part of the problem. At least let's mark them A, B, and C. So we're not done. Now we have to find the partial derivative of this, of 40 comma 5x minus y to the seventh in regards to y. So what we're going to do is multiply this out. So 7 times 40 is 280. 5x minus y to the sixth, and then times the derivative of what's in the parentheses in terms of y, not x, because now we're doing the partial derivative of y here. So it's times negative 1, since we have negative y. So then that gives us a final answer of negative 280 5x minus y to the sixth. So that is the answer to our first problem. On to the second part of the problem. The only difference between this part B and part A is that now we have to take it back and take what we got in part A and take the partial derivative again in terms of x. So it's not actually as daunting as it may look. So what we're going to do, we're going to take the derivative again. So we have negative 280 times 6. What is that? I believe that is 1,680. So we're going to do negative 1680 5x minus y to the fifth times the derivative again of what's in the parentheses in terms of x. So that's times 5. So then 1680 times 5, that's going to be 8400. So that gives us a final answer of negative 8400 5x minus y to the fifth. And so that's our answer for this one. Let me just box these so that we know what our answers are. And lastly, what we're going to get, we have the partial derivative of x squared, and then the partial derivative of y. So essentially, this is the same as this. This is the same, because partial derivative of this of x twice, same as partial derivative of x squared. So what we're going to do is we already found what the partial derivative was of this whole problem in terms of x. So that was 40 parentheses 5x minus y to the 7th. So then we're going to do the middle part and take that in terms of x this time instead of in terms of y like we did for part A. So then we're going to take the derivative, so of 40 parentheses 5x minus y to the 7th. So that's 7 times 4, which is 280. 5x minus y to the 6th. But this time it's going to be times 5, since again it is the partial derivative in terms of x. So it's going to be times 5. And 280 times 5 is going to give us 1400. So that equals 1400, 5x minus y to the 6th. Now, that is not our final answer. We have one more step, which is to take the partial derivative in terms of y of what we got here. So what we're going to do is take our derivative. So we have 1400 times 6. That's going to give us 8400. 5x minus y to the 5th, and then times the derivative in the parentheses of y, which is -1. So we're going to get a final answer for this of -8400 5x minus y to the 5th, which, if that looks familiar, that's because it is, because that is the same answer we got for part B. But you know, it's not necessarily, it's for this problem it happened to be the same, but that's not necessarily always going to be the case. Make sure to always find the partial derivatives. Don't get lazy. Split it up. I like to split it up. When you're given x squared, split it up. Partial derivative of x twice, then partial derivative of y. It makes problems that seem more daunting not as difficult. And yeah, that's Webwork 10.